हेलो दोस्तों, कैसे हो आप सब। आई होप कि आप सब खैरियत से होंगे। तो आज हम एक नया इंटरेस्टिंग टॉपिक डिस्कस करने वाले हैं, दैट इज़ द बेस ऑफ नेचुरल लॉगरिथम ई। वेयर दिस ई कम्स फ्रॉम। हमें कैसे पता है कि जो ई का वैल्यू है दिस कम्स आउट टू बी 2.71828। आज हम इसी चीज़ को डिस्कस करने वाले हैं कि ये एक्चुअली ये द कांस्टेंट वैल्यू ऑफ ई, वेयर दिस कम्स फ्रॉम, ये कहाँ से आया और ये किसने डिस्कवर किया था। फर्स्ट ऑफ ऑल, दिस ई इज़ आल्सो नोन एज यूलर्स नंबर। इट वाज एक्चुअली यूलर, a great mathematician who discovered this. This is also known as Euler's number. Now, if we talk about logarithms, we have two types of logarithms. That is common logarithm and natural. Common log and natural log. Now, in case of common log, the logarithm to the base ten, वो लॉगरिथम जिसकी बेस 10 है, जिसकी बेस 10 होती है, तो उसको हम क्या कहते हैं, कॉमन लॉगरिथम. Suppose we can write we have 100 is equal to 100. This is true. And we can also write this 100 is equal to 10 raised to power 10. This is the power form, exponential form of this. 10 raised to power 2. 10 times 100. Now we can write this also in this way. That is log. If we convert this in terms of log, that is log 100 comes out to be 2. But this is only possible when the base is 10. तब जाके किसके बराबर बनेगा, द log of 100 comes out to be 10. 2, sorry, when the base is 10. When base is 10, उस वक्त हम इसे क्या कहेंगे, that is common logarithm. But you will not find always this base 10. आपने ये हर जगह पे ऐसे नहीं देखा होगा कि हमें बस हम बेस 10 ही इस्तेमाल करते हैं. बहुत सारी जगह आपने देखा होगा कि हम वहाँ पे log e इस्तेमाल करते हैं. सिंपली एक्सपोनेंशियल फॉर्म ई रेस्ट पावर एक्स, ई रेस्ट पावर 2x, ई रेस्ट पावर आयोटा एक्स, ऐसे कुछ फंक्शंस हमारे पास होते हैं. तो वहाँ पे जो हम लॉग इस्तेमाल करते हैं, वो जो बेस इस्तेमाल करते हैं, एंड दिस बेस एंड दैट बेस वी कॉल एज नेचुरल लॉग. नाउ नेचुरल लॉग, हाउ वी डिफाइन नेचुरल लॉग. द लॉग टू बेस ई इज कॉल्ड नेचुरल लॉग. उस लॉगरिथम की जिसकी हमारे पास बेस होगी क्या, ई, तो उसको हम क्या कहेंगे, नेचुरल लॉग, नेचुरल लॉगरिथम. Now let me show you how. Let's rub this because now our focus is on this natural logarithms. Let's see this. This is our e. Now see here. I'll write here. Suppose I have a function that is y is equal to ex. हमारे पास होते हैं ऐसे कुछ फंक्शंस, इस तरीके की फंक्शंस भी होते हैं. तो अगर मैं इसको लॉग में कन्वर्ट करना चाहता हूँ, एंड दिस इज हियर द बेस, जैसे कि वहाँ पे हमारे पास 10 रेज़ पावर 2 था, दैट इज द बेस 10, and 2 is the and then 2 is actually the power, and this base is actually here. If we talk about this is common logarithm. In case of common logarithm, in case of natural logarithm, here we does not find any 10. We here we have e, and this, then we call this as a natural logarithm. Now see this. If we convert this in log, then we can write log y is equal to x, but only when base is e, and this base, when this base is e of any function, any logarithm, we call this as natural logarithm. This we can see this natural logarithmic equation. Now the value of this e is 2.71828. Where from this dash 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 dash? This is 2.71828 dash 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 dash. First of all, you must know this value of natural logarithm e is actually irrational number. We cannot write, we cannot, this cannot be written. We cannot not write this in simple form. That's why we call this as irrational number. Now in order to prove this, we can use here Taylor's series. Oh, let me rub this first. As you know, the Taylor's expansion of ex. Suppose we have a function y is equal to ex. Because we take this function, because we can directly then use x is equal to 1, we get y e simply, and we can easily find its value. Now in terms of Taylor's expansion, as series, we can write this, that is ex is equal to 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial plus x4 divided by 4 factorial. Stop here, dash 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 plus x raised to power nth divided by n factorial. Now this is the Taylor's expansion of e raised to power x. If you does not know how this expansion comes out to be like this, then you can go, I will, मैं इस पर नया वीडियो बनाऊंगा, वहाँ पे हम पर्टिकुलरली टेलर्स एक्सपेंशन पे बात करेंगे, टेलर सीरीज पे बात करेंगे, हाउ वी कैन, हम उसकी वहाँ पे ये जो एक्सपेंशन है, हम इसको कैसे वहाँ पे प्रूव कर सकते हैं कि दिस कम्स आउट टू बी इन दिस वे. Now here you must remember this. Now when we put, let's put directly, put x is equal to 1. When we put x is equal to 1, we can write e raised to power 1, that is e. Okay, this comes out to be 1, this is also 1, plus this is 1 divided by 2 factorial, that is 2, plus x raised to power 3, that is 1 divided by 6, because 3 into 2 into 1, 3 factorial is equal to 3 into 2 into 1, plus x, sorry, when x we put x is equal to 1, this we can write 1 divided by 4 into 3 into 2, that comes out to be 4 3s are 12, 12 2s are 24, plus let's add one more. अब जितने हम इसमें ज़्यादा से ज़्यादा इसको सम अप करेंगे, ऐड करेंगे, उतना हमारा जो रिज़ल्ट है वो उसमें जो एरर्स हैं वो ज़्यादा हमें सही आएगा. बट वी डज नॉट ऐड हियर lot more, we just add these simple 5-6 terms. I can write here 1 divided by, when we put x raised to power 5 and 5 factorial, this comes out to be 1 divided by 5 multiply 4 is called 20, 23s are 60, 62s are 120, and this comes out to be 120. Now let's simplify this. Simplify this in this way. That's e is equal to 1 plus 1 is equal to 2 plus 1 by 2 plus 1 by 6 plus 1 by 24 plus 1 by 120 is equal to, take these two terms here first, multiply this term numerator by 3 and denominator by 3. This comes out to be 3 by 6 plus 1 by 6. This comes out to be, we can directly write here 4 by 6. That is 4 by 6 plus 1 by 24 plus 1 by 20. Now let me simplify these two terms first. 6 2s are 12 plus 4, 16 by 6 plus 1 by 24 plus 1 by 20. Now let me rub this first. That is equal to, if we multiply this first term by 6, 4 and denominator by 4, this comes out to be 16, 16 are 32, 64 divided by 6, 4s are 24 plus 1 by 24 plus 1 by 20. Now let me rub this whole. Now base are same, power should be added. That's e is equal to 65 divided by 24 plus 120. Now multiply this first term by 5, numerator and denominator by 5. This comes out to be 65 5s are, that's 5 5s are 25, 2 5 6 are 30, 32, 325 divided by 24, that's 120 plus 1 by 120, and this comes out to be 326 divided by 120. Now let me divide this 326 by 120. Is equal to 326 divided by 120. When we divide this 326 by 120, as 123s are, sorry, 122s are, comes out to be 240, and here we get 6 as 6, 12 4, this comes out to be 8, and this. Now we use here decimal, and it comes out to be 0. 127 comes out to be 840. Let's see this how. 120 multiply 7. 7 zeros are 0, 7 2s are 14, 1, 7 1s are 7 or 8. Now here we get 20, and let's add some 0, and 120 1s are, that's 120, that is 80. Yeah. Now if we use another 0, that is 800, it comes out 800. We'll see 127 no 6 are. Now here if you find some deviation from this value to this value, this is only because we does not add all these terms, and the result comes out to be, that is our 2.716. The original is equal to 2.71828 our result comes out to be that's e is equal to 0.716. The deviation in this result is only due to this, because we does not add all these expansion terms. If we add all these expansion terms, we get the same result as the original value of this exponential term e. This is the proof of this e. This e is actually the base of this natural logarithm what we use. This we call this as natural logarithm. That's why, because this comes out to be we does not this is not naturally invented. This is discovered by Euler, and we find this sequence, this constant in every wire, in every mathematical, in every physical structure. Uh, the physical things behave in this like this. That's why we call this as natural logarithm. We'll discuss on this later. मैं इस पर और एक वीडियो बनाऊंगा जिसमें हम फिर देखेंगे कि इसको हम नेचुरल क्यों कहेंगे, कि कैसे जो हमारे फिजिकल स्ट्रक्चर्स हैं उनमें ऐसे हमें दिखाई देता है. नाउ थैंक्स फॉर टुडेज वीडियो, थैंक्स फॉर watching. Thank you so much.